I'll discuss here dimensional analysis. Discuss the dimensional analysis. What is actually the dimensional analysis? The answer of what is dimension you will try to find out, and otherwise refer my previous class. You will get it there. So what is dimensional analysis? So dimensional analysis of it is the analysis of relations among different physical quantities by identifying their basic quantities. You can say it is a method of analyzing the relationship between physical quantities by examining their dimensions like length, mass, time, ampere, that means the current, etc. What is dimension, or what do you understand by dimension? Use of that dimensional analysis, if you are studying that, so what is the use of this dimensional analysis? That all is to be kept in mind. So there are certain quantities, different kind of quantities you might have studied, and in previous class we have discussed all these. The physical quantity, just try to find out the answer, what is the physical quantity and which quantities are called physical quantities. Just like the example is length is the physical quantity, speed is physical quantity, the density is there. Is the intelligence a physical quantity? So try to answer these questions and find out the answer of these questions. I'll discuss here dimensional analysis. There are three uses of dimensional analysis. The first is to check the consistency or the correctness of a relation dimensionally, number one. Number two, to establish the relationship among different physical quantities on the basis of dimensional analysis. And third thing is to convert the units from one system into another system. We will discuss these step by step or one by one. So first of all, I will discuss the checking the or correctness or consistency of a relationship. So the first application of the dimensional analysis is to check consistency of a relation, that is dimensionally. What do you mean by dimensionally? Dimensionally means you might have heard about the, or you know about the relation F is equal to MA. So if there is 6 MA, so whether it should be 6 or 3 or 1, this cannot be found here with the help of the dimensional analysis. Only the thing is whether this has to be M into A or M upon A, or it should be A by M. These things can be checked, that whether this relation is correct or this relation is correct or this relation is correct. You know this is correct, but dimensionally you can conclude and you can come to know which one relation is absolutely correct dimensionally. As far as these constants are concerned, this is the limitation of dimensional analysis, that with the help of the dimensional analysis we cannot decide or we cannot check whether exactly the constant this 6 or 1 has to be there or not. So this is the limitation of the dimensional analysis. We can discuss later on also. So first of all, let us check this relation, the correctness of this relation, whether it is exactly correct or not. Although you know it, but we can see it. So the relation is F equals to MA. Let us check it. So for that, you have to follow these steps I am telling you. So first of all, you have to take LHS. So LHS is F. And mind it, to solve these questions, you must be well versed with the dimensional formula of different physical quantities. So practice those things. Again, you see this in the how to derive the dimensional formula of a physical quantity in my previous class. So here, this is left hand side, that is force. So giving dimension side equals to, the dimension of the force is m1 L1 T minus 2. Now the right hand side is equal to m into a. Again, giving dimensions, we get RHS equals to, the dimension of the mass is m1 L0 T0. The dimensions of acceleration, A is acceleration, is m0 L1 T minus 2. Now multiplying this according to the law of indices, we'll have m1 plus 0, so this is 1. Then here it is L0 plus 1, so it is L1. Here it is T0 and T minus 2, so that will be T minus 2. So this comes here, and we see the LHS and the RHS are here same. So here LHS is equal to RHS. This is LHS. So we have come here, we have come to analyze that LHS is equal to RHS. Therefore, the given relation is correct dimensionally or now we will check another relation, and the relation is T equals to 2 pi under root L by G. The time period of a simple pendulum is given by T is equal to 2 pi under root L by G, where T is the time period, L is the effective length of the pendulum, and G is acceleration due to gravity. Again, the similar way, first of all, we have to take LHS, that is equal to T. Now, giving dimensions, when you will give the dimension, so the dimension of the time period will be, so LHS will be, time period, the dimension is M0, L0, T1. So our left hand side will be M0, L0, T1. Now the right hand side RHS is equal to 2 pi under root L by G. Now again, giving dimensions. So when we will give the dimension to this, so this 2 is constant, so it is dimensionless. This pi is also dimensionless constant. So the RHS will become, the dimension of the length are M0, L1, T0, and divided by acceleration gravity. Acceleration due to gravity, the dimension of the acceleration due to gravity G will remain same as that of the acceleration. So the dimension of acceleration is M0, L1, T minus 2. And this whole power half, because it is under root. So here, according to law of indices, when they are divided, these powers are subtracted. So this will be M0 minus 0 will remain 0. So L1 minus 1 is 0. 1 here, 1 minus 1 is 0, and then t is 0 minus minus 2, then that becomes 2, and the power is half. So this becomes m0 L0 T1, which is same as that of the LHS. So here we have LHS is equal to RHS. So LHS and RHS are both same, therefore given relation is dimensionally consistent or correct. So we can only check dimensionally whether this relation is correct. If it is written 3, then we cannot check. This is the limitation of the dimensional analysis. We will discuss it later also. So once again we can see here the t time period is given by 2 pi under root L by g. So first of all we will take the left hand side, and the LHS is t, and giving dimension of that left hand side we get LHS is equal to m0 L0 T1. Now we take RHS, that is 2 pi under root L by g. So giving dimensions again here we get the RHS is equal to that, after giving the dimension to the length, that is m0 L1 T0, and divided by the dimension of the g, that is m0 L1 T minus 2, whole power is under root, that means half. So when we divide by this quantities as well, then according to law of indices the powers are subtracted. So m power 0 and 0, so 0 minus 0 is remains 0, L power 1 minus 1, that becomes 0, and here t power 0 minus minus 2, that becomes 2, and whole power half. In case of the indices, when the powers are power, then they are simply multiplied. So 0 into half, that is 0, then 0 L ki power 0 into half is L0, and here L ki power t ki power 2 into 1 by 2, that remains 1, that becomes n1. So then dimensions come m0 L0 T1, which is same as that of the LHS, so it is equal to LHS. So here we find LHS equal to RHS, therefore given relation is dimensionally correct or consistent. So this way we have to do, and always we have to follow this these steps. Now we can take third question. This F is the viscous force or the air drag is given by 6 pi neta RV. That means this Stokes force is given by 6 pi neta RV, where F is the viscous force, this 6 is constant, pi is also constant. This neta is called coefficient of viscosity, this R is the radius, and V is the velocity. So here, to check this, whether this relation is dimensionally correct or not, we have to follow again the same way. So first of all, we will take LHS, that is equal to F. So here again, giving dimensions, we get LHS is equals to, the dimension of the force is F equal to MA, so that is M1 L1 T minus 2. Now we take RHS, so RHS is equal to 6 pi neta R and V. So here again giving dimensions, so first of all we have to give the dimension of the 6, that is dimensionless, pi is again dimensionless, then neta. So this neta is the viscosity coefficient, and this neta, these questions you will be able to do only when you are very much familiar with all the dimensions of different physical quantities. So here if you don't remember, then according to the formula you can derive it. So neta is defined as force per unit area per unit velocity gradient. So here, this is the force per unit area, that means pressure. So it is M1, L minus 1 and T minus 2. And here it is velocity upon distance. So that is M0, L0 and T minus 1.